Inverse relationships are mathematical relationships that will undo each other. So for example, addition and subtraction are inverse relationships. If you add something and then subtract it, you're going to end up with what you started with. Let's take this example down here. X, we're starting with X. If we add Y and then we subtract Y, we end up with what we started with, which was X. Or another example, if we subtract -2 and then add 2 to X, we end up again with X. The 2's cancel out. Another inverse relationship is multiplication and division. If you multiply an amount by something and then you divide it by the same thing, you're going to end up with what you started with. So X times Y, and then if you divide that result by Y, the Y's are going to cancel out and you're going to be left with X. The same thing goes for this example. 2 divided by 3 would give you 2/3, and then if you multiplied 2/3 by 3, the 3's would cancel out, and you would still end up with 2. So multiplying and dividing things by the same amount undoes the effect, and so multiplication and division are inverse relationships. Similarly, radicals and exponentials are also inverse relationships. If you raise a value to a certain power and then you take the root of the same power, you're going to end up with the original value that you began with. So for example, 2 squared and then raised to the 1/2 is going to give you 2, because raising it to the 1/2 is the same as saying you're taking the square root of it. 4 squared taken to the root of 2 is the same as just saying 4. If I were to raise 3 to the 10th, but also took the 10th root of 3 to the 10th, I would end up with just 3. So radicals and exponentials are also inverse relationships. Another way of looking at this is seeing if you raise 3 to the 5th power and then take the 5th root of 3, that's the same, if you remember our rational exponent properties, that's the same as saying 3 to the 5, and then that index over here is the denominator of the rational exponent, so that's the same as saying 3 to the 5/5, and 5/5 is just 1, so it's the same as saying 3 to the power of 1, which is 3. Y to the x, and then taken to the root of x, is the same as saying y to the x over x, which is equal to y to the 1, because x over x is 1, which is just y.